morning, my good partners in learning. I believe you have settled down and you are ready to learn. This is time for science. In our class, we normally say science time, bracing time, and bracing time, science time, and that is nature. Wow! Welcome to our topic in science. It's about electrical energy. Electrical energy. But before I start my topic, I would rather love to make you take care of yourself. You know, there are several diseases that are in our community right now, especially the most dangerous disease this time is COVID-19, coronavirus. Now, how do you take care of yourself? You should make sure that you wash your hand with water that is running, but also use a soap. Use a soap, or if you have other sanitization mechanism, it is advisable to use them. Be reminded that corona disease is real. Let us take precautions, and for today, I remind you to wash your hands with soap and running water. But also, when at home, please make use of environmental conservation. It is very important to make our environment friendly to us, because if we make our environment friendly, we shall live in a good life. For example, if we plant trees, we get good air. So welcome to this topic about electrical energy. What is electricity? What is electricity? Electricity is a form of energy. Electricity is a form of energy like any other forms of energy like light, sound, and so forth. Electricity is a form of energy. But in this topic, I want us to be able to calculate some calculation in the circuit or electric circuit. But also, I want us, before the end of the class, we must be able to calculate voltage, to calculate resistance, and also to calculate current. I want you to be able to solve a problem like this. In this problem, we are given resistance. This is ohms. This is the symbol of resistance, ohms. So this one is resistance. But this one is voltage. We are not given the amount of voltage in this circuit. But also this one is current. We are given the current. So definitely this question requires us to calculate current. It can ask you calculate the voltage. Calculate the voltage in this circuit. Calculate the voltage in this circuit. I'll definitely show you or explain to you slowly by slowly how to calculate voltage, but also how to calculate resistance, also how to calculate current. Let us start by step 1. Having you understand that you know what is electricity. Electricity is a form of energy. But let us understand some sources of electricity. Where do we get electricity from? Where can we fetch electricity? Sources of electricity. We say sources of electricity. Sources of electricity. We have one example. Just examples, because we have many thousands and thousands of sources of electricity. But I'm just giving some few examples of sources of electricity. One, falling water. The falling water gives us a form of electricity known as hydroelectric power. Hydro gives us hydro. Hydro means water. Hydro means water. Wherever you see the word hydro, it deals with water. Hydroelectric power. So falling water is a source of hydroelectric power. Falling water is a source of hydroelectric power. But we have hot springs. Number 2, we have hot springs. Hot springs, or we can say hot steam. Hot steam. Let me give you a short example. When you take a kettle and put it on fire, it produces some steam. When you put some water in a kettle, put it in a fire or some source of heat, and then give it some times, it will start boiling. The water inside the kettle will start boiling. After some times, the kettle has got certainly, I'm just drawing a rough one. This is my rough kettle here. My rough kettle, it has got something like this, and then this is the handle here, right? Then you have put this kettle in fire. Assume this is a source of fire. This is the kettle. Now it has got some water inside here, and then this fire is on. This water in the kettle is now boiling. This kettle will start producing some steam through this releaser. It will start releasing some steam. This is steam. Now this steam is the one that I'm talking about, hot steam. I don't mean this electricity, I don't mean this kettle can produce electricity, but I was just giving you an example of steam. This is how steam is produced. Now mark you, under the ground we have hot cluster. Under the ground on our earth we have hot cluster, burning fire down there, or burning gases. When they burn, then they make water that is on top of it to start producing steam. And this is the steam I'm referring to. The springs which are hot, or the steam that is hot, it produces also electricity. If it is well trapped, it can produce electricity. And this now electricity, we call it geothermal. Geothermal power. That's another source of electricity. Hot steam or hot springs, they produce an electricity known as geothermal power. But we have the sun, normal sun that you see outside here. The normal sun you see outside here also can produce electricity, but how does it produce? I think there you are seated down there, or you're standing. You can think about how sun can produce. How can sun produce electricity? How does it come and the sun give us electricity? Are you thinking of something? How does the sun produce electricity? How can we make this sun give us electricity? Alright, let me come down here and write number 3. We say sun. The sun, through something we call solar panel. Through solar panels, the sun now can give us electricity. These solar panels are put or kept on top of roofs, or else you can just set a place whereby you set your solar panels, and then they will trap the sun during the sunny days. These solar panels will trap the sun. After trapping the sun, they will convert that sun, because they have some mechanism inside them. They have, the solar panels, they have been made with a mechanism that will convert that sun to electricity. Now that electricity that we get from sun, which passes through the solar panel, we call it solar power. We call it solar power. That is another source of electricity. That is another source of electricity. Now we have another source of electricity, generators. The generators that are bought from industry. There are big generators, there are small generators, there are medium generators, small generators, and we have big generators. Those generators are source of electricity. Generators are also source of electricity. We can write number 4, generators. Generators, source of electricity. But number 5, we have the windmill. The windmills. The windmills. Windmills also are source of electricity. A windmill is a sort of a project whereby some posts are set in a place where there is strong wind. Some posts are set, and then we have some wind vanes. We have some wind vanes that will rotate. These turbines will rotate and will make this wind produce electricity. It will connect the turbine will connect to the generator, and then the generator will be forced to produce electricity by this windmill. I'm just giving some examples. Number 6, dynamo. Dynamo is also a source of electricity. A dynamo is also a source of electricity. I believe some of you got some bicycles at home, and if you check your bicycle, there might be something that makes your bicycle during the night seasons. It can produce light. During night time, it can produce light. Now that thing that is just near to your tire, bicycle tire, which is connected to the bicycle tire during the night time, and then it is rotated by the bicycle tire, and then makes your torch, your bicycle torch, light. That thing that makes this all this happen, and you see the light, that mechanism there is known as dynamo. That dynamo is a source of electricity. That dynamo is also a source of electricity. But the last one, because we have many of them, I told you, we have the dry cell. The dry cell is the normal cell that you connect to your torch, the home torch. You put one cell, and then that is the one we call a dry cell. But if you put more than one, then it can be a battery. You can call it a battery. But let me come down here and we try to calculate the electricity in a circuit. Before we go to that point, I believe you're taking some simple notes. On sources of electricity. But now, let us come down and see an electric circuit. What is an electric circuit? Please answer me. What is an electric circuit? What is an electric circuit? What is an electric circuit? An electric circuit is a path through which electric passes. Is a path through which electricity passes, or we can say is a path of electrons. Now, let us understand some parts of electric circuit. but we can understand the parts of electric circuit by drawing an electric circuit. I believe some of you know how to draw an electric circuit. Can you please try to draw it yourself? An electric circuit. Let me assist those who cannot. An electric circuit. This is how you draw it. This one here is a battery. When it's more than one, is a cell. But this one here is a bulb. Then we come here, we have a switch. But here, we can as well put something else, we call it a fuse. And then we have the wire. Now, you can ask yourself, how many batteries are here? We have a dry cell 1. This one is positive. This one is negative, positive, negative, positive, negative. How many are they? 1, 2, 3. We have 3 dry cells, and we can now call them a battery or battery, right? So this one is a dry cell. 1 is a dry cell, but if it is more than 1, we call it battery. What about this one? It's a bulb. What about this one? It's a switch. What about this one? It's a fuse. What about this one? A wire. Those are the main parts of a switch. Those are the main parts of a switch. But I want us to get into details on the parts of a switch. Parts of a switch. I want us to get into detail parts of a switch. Parts of a circuit, Parts of an electric circuit. Parts of an electric circuit. Parts of an electric circuit. We have source of electricity. 1. Source of electricity. That is 1. We have 2. We have the wire. We have the wire. 3. We have the switch. We have the switch. But 4, we have the load, such as fuse or bulb. Those are parts of electricity. But now let us see the parts and their function. The parts and their function. The parts of electricity and their function. Parts of electricity and their function. We have here parts. Here we have functions. We have the parts and functions. We have 1. Source of electricity. Source of electricity. In this case, we assume the dry cell is our source. In this case, we assume that the dry cell is the source of electricity. What is the function of a dry cell? The dry cell functions as the producer of the electricity. The dry cell is the producer of electricity. But we have the wire, number 2. Wire. What is the function of the wire? It is a pass, or where the electricity passes through. It is where the electricity passes through. It is where the electricity passes through the wire. But we have now number 3, switch. Number 3, switch. The switch. The switch is used to complete or to break a circuit. A switch is used. A switch is used to complete or break a circuit. A switch can be used to break or to complete a circuit. For example, in this one, we can see the switch has broken the circuit. But when we combine it, when we join it like this is the switch. Now we see the circuit is complete. The circuit now is complete. But when it was open, we say the circuit is broken. It's not complete. But now we have the load or the bulb. Let us assume our load here is the bulb. We assume our load here is the bulb. Number 4, the bulb. We assume our load here is the bulb. The bulb. What is the function of the bulb? It is an electric appliance. It is an electric appliance. It is an electric appliance. This is where all this energy is cultivated to, so that it can get into use. Our load here is a bulb. This is where all the energy in the circuit is cultivated, and then it gets into use. For example, if you needed some light, this is where all this energy will be cultivated in the bulb, and then it will produce the light that was needed. Hope we are moving on well, and now you understand how to draw a circuit and how to name the parts of the circuit. Can we now please get into the calculation? Remember, at the end of the topic, you need to understand how to calculate voltage, how to calculate resistance, and how to calculate current. Can we now move to calculation of all these? Okay. Now, before we get in calculation of electric circuit, before we get to calculate the voltage, the resistance, and the current, it's very important to understand the symbols of electric circuit. The symbols are also very important, and I have experienced my students confusing the symbols. So it is very important for me to clarify these symbols, and then you shall cooperate with me to mention them. Now, I'll draw a table here. Here I'll show the symbol, but this other side, we shall write a name of the symbol. For example, 1, I want you to tell me, what is this? That is a symbol of electric circuit. What is it? It's a wire. When you see a line like that, that is a wire. That is number 1. But we have number 2. What is this? That is 1. It's a dry cell, because it is just 1. A dry cell. But if I had drawn this way, 1, 2, 3, and so forth, that is more than 1, we call them battery. Battery is double T. Battery. But we go to number 3. We have another one here. A fuse. This is a fuse. That is a fuse. When it has a line in between there is a fuse. But we have number 4 here. This one. What is this? This one is resistance. Resistance. That is resistance. That is resistance. Now we have the wire, we have the bulb, we have the battery, we have the wire, we have the dry cell, we have the battery, we have the fuse, we have the resistance. Number 5, we can mention this one here. This one is a bulb. Bulb. That is a bulb. But we have another one here. When you see number 6 here, when you see something like this, and then here, that is a symbol of an instrument known as ammeter. An instrument used to measure current. An instrument used to measure current. An ammeter. 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 An instrument used to measure current. We have another one, 7 here. That's another one there. What we call this one? This one is also a symbol of an instrument that is used to measure voltage. Used to measure voltage. So this one is a voltmeter. Voltmeter. A voltmeter. But we have another one. Let me continue. I hope you are taking note on this. Let me continue. We have another one. I want to clarify before we start calculation. We have another one here. Number 8. I want to draw this one here. Looks like a cartoon. What is this? This one here is a symbol of a socket. A symbol of a socket. A socket is a symbol of a socket. Number 9. We have a symbol here like this. That is a symbol of an instrument used to measure speed of electricity. We call it galvanometer. We call it galvanometer. Galvanometer. Galvanometer is an instrument that is used to measure speed of electricity in a circuit. Those are some of symbols in an electric circuit. Those are some of the symbols in an electric circuit. Now let me go direct to how we calculate such a problem. How do we calculate such a problem in a circuit? How do we calculate voltage? How do we calculate ammeter or current? How do we calculate resistance? How do we calculate them? This is when now you should take very important seriousness so that you can understand how to calculate them. Please be attentive so that we can calculate them together. Now we start with number 1, how to calculate voltage. How to calculate voltage? Actually, in our diagram, we are not given the voltage. And then the question is asking, calculate the voltage of this circuit. Calculate the voltage of this circuit. During this calculation, I want to give you a very, very important formula, and you should never forget this. Whenever you are calculating such problems here in an electric circuit, please draw a small triangle there, and then you divide it 3 times like this, and you see that way. Now here write V, here I, here R. If you understand this, this is when you are capable to solve problems in an electric circuit. V means NB or note. V means voltage or volts. Voltage or volts. I means current. Current can be given in A. Remember, I told you when you see such a symbol, I have already told you this is an instrument that is used to measure current. Therefore, when you see a symbol like this, a circle and an A inside, that one requires you to understand this is current. And then now, this is how we calculate current. I equals to current. Let us come to R. R is resistance. R is resistance. Having that in mind now, you are in a position to make formulas. You are in a position to make formulas on how to calculate some calculations or some volts, some resistance, some current in a circuit. Formulas now. Formula on circuit. You are told to calculate the voltage. But now I want to clarify, how does this line mean? How does this line mean? How does this line mean? This line, when you are given a V, and then there is a line here, I, this means I divided by V divided by R. This one, when you divide them, you get what? Resistance. But we have another line here and another letter here. This means V divided by R. You are going to get I, which is current. But we have another line here. This means I multiply by R equals to V. In simple calculations, we can say R equals to V over I. R equals to V over I. But we have I equals to V over R. But we have V here. V equals to I multiplied by R. Therefore, it is now very, very simple to calculate. It is very simple now to calculate voltage here now. So we are told calculate the voltage in this circuit. V equals to, we come here and take I multiplied by R. I multiplied by R. Now where is I? This is I. This is R. So we say V equals to 20, that is current, multiplied by R, which is 5 ohms. 5 ohms. Okay, what do you get? V equals to this one multiplied by this one, you get 100 what? V or volts. That is how we calculate voltage in a circuit. That is how we calculate voltage in a circuit. I believe now you understand how to calculate voltage, how to calculate resistance, how to calculate current. This is our topic on circuit calculation in a circuit. My name is Joseph Mendio from Lightway Schools. Welcome. I shall be coming back for more clarification together. Thank you.